Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in 8051 microcontroller. We're going to see data transfer instructions, right? In previous videos we already started the instruction set of 8051. We have completed arithmetic instructions and logical instructions, and today we are seeing about data transfer instructions. Right, this is very important concept in instruction set. You have to logically understand what is move operation, where we will use push and pop operation, and where we will use exchange instructions. Right, it's not going to be very simple like the addition or subtraction instruction. This concepts is bit technical. You have to understand the logic behind it, where we literally use push and pop operations and all those things, right? And when it comes to data transfer instruction, from the name itself you can understand we have to move a data. Whenever we have to move a data between a registers or between a register and address, we use this type of instruction, right? And I'll just give you just outline move instructions. We have different types of move instructions. We will see that that is moving between registers, moving between the external address, or moving between the internal RAM or external RAM, like that, right? We will use move instructions. And coming to push and pop instruction, you have to understand where we will use push and pop instruction. That is, we will push any particular address to the stack, right? Whenever you want to put any particular information to the stack pointer, right, then we will use push instruction. And whenever we want to remove an instruction from the stack pointer, then we will use pop, which means push instruction will increment the stack pointer and pop instruction will decrement the stack pointer, right? And where we will use it mostly, whenever there is an interrupt, we will use push operation and pop instruction, right? So what is meant by interrupt, right? We will see interrupt in depth about interrupt in unit 2, but I already explained what is interrupt in unit 1 when we saw about the architecture, right? So interrupt is nothing but whenever a microcontroller is executing a program, right, a main program, right, when there is some other instruction which comes in, which interrupt, say for example it can be a timer interrupt or it can be an external interrupt, right? Whatever interrupt, it just tells the microcontroller you have to do this instruction immediately, like that. So what microcontroller will do is it will serve this interrupt, that is, it will go to the memory location which is given by that address, and then it will serve it, and then it will return back to this main address, right? And during this operation, right, that is the microcontroller, right, it has to push the address of program counter to the stack pointer, and similarly while returning from the interrupt to the main program, it has to remove the address from the stack pointer to the program counter. You will understand those concepts in unit 2, right? But that is the use of push and pop instruction, right? And exchange instruction, from the name itself you can understand we can exchange the bits, right? That is why we call it as exchange instruction, right? We will start what is move instructions, right? When it comes to move instructions, that is when it comes to data transfer instructions, we have these three, that is move, destination source, destination comma source, and similarly push source or pop destination, similarly XCH, that is exchange, destination and source. In all the instructions you will have destination comma source, as I said, right? And when it comes to 5 data transfer, you can see these are the 5 different opcodes which we use, okay? Move, move X, move C, and push and pop, and as well as exchange, right? And you got to understand here this move instruction, right? Whenever you got to understand the difference between all those three. Whenever we have to do a data transfer between 2 register or between a register to an accumulator, right, just a normal data transfer, then we will use this move instruction, right? And whenever we need to access, that is move the content to the external address, right, the external address, we use this particular move X instruction. Already you would have used this instruction in your lab programs where you would have used move X DPTR 4500, something like that, right? That is, we are accessing the external address, right? So that is represents move X. And move C, whenever you want to access the internal and internal ROM, then we'll use this move C instruction, right? And push and pop, I have already said what is that operation, and exchange is nothing but changing the exchanging the nibble values, right? And you can see this diagram where move X, right, we will access the external RAM, right, and similarly move X, it accesses the external RAM, right, and if it is move C, it accesses the internal and external ROM. Move C, it accesses the internal and external ROM. And the normal move operation, right, any just move, that is if it is move R1 comma R2, just between two registers, we can do a data transfer with simple move instructions. Right. Now coming to this instruction, you can see here move X A at DP RP. Right. Now you can understand there is some external address, right, given at RP, that is at, right. So what does it mean? Copy the content of the external address, the RP, to the accumulator. We are accessing the external address at RP. Similarly here at DPTR. Similarly at RP. Similarly at DPTR. Right. So we are accessing the external address, that is why we are using move X. And similarly here, what we are going to do is we are going to move this value to the accumulator. But here what we are going to do is we are going to move the accumulator value to this external address. Similarly, what we are going to do here is we are going to move the accumulator value to the DPTR. Right? So this is about move X instruction. Right? And when it comes to move C, as I said, we will access the internal and the external ROM. But when move X is something, we will use only the external address. Here we use internal and as well as external ROM, right? And you can see this particular instruction, right? Move C A some value. That is the address. This has to be calculated, right? The address, the content present in this particular memory location. But the memory location we have to calculate. That is, microcontroller has to calculate it. That is, it has to add the accumulator value and the DPTR, so that it can find out the address, the code byte, right? So that the information in that particular address has to be moved to accumulator. You can see that the copy the byte, code byte found at the ROM address formed by adding A and DPTR. Whatever value which is found in the address, right? Address which is found, which is calculated by adding A and DPTR. You will get some, say for example, by adding A and DPTR, you get some address location like FF0H, right? Then the content which is present in this particular, we have to go to this particular memory location. We have to get that content, and that content has to be moved to the accumulator, right? Similarly here, right, we have to calculate the memory location. Memory location is calculated by using the accumulator value and the program counter, and then that content is moved to the accumulator, right? That is move C instruction. Basically what we are doing here is we are just accessing the internal or external ROM by using move C instruction, right? And as I said, push and pop instruction, whenever we need to push a content to the stack pointer, right, then we will go for push operation. Whenever we remove the instruction from pop, then from the stack pointer, then we will use pop instruction, right? You can understand this by when you are looking up, when you are studying about the interrupt concept, right? That is, the microcontroller has to switch between a main program and a subroutine program. To go to the subroutine program, right, before going to the subroutine program, what it will do is it will push the instruction which is in the program counter to the stack pointer, right? That is because while after serving the subroutine, it has to come back to the original program, right? To come back to the original program, what it will do is the pop operation. It will remove this particular address which is saved by push operation to the program counter, right? That is why we use push and pop instruction. And whenever we say push, it increments the stack pointer, and whenever we say pop, it decrements the stack pointer, right? And you can see push add, that is it will push this address to the stack pointer, increment the stack pointer, copy the data in the address, right, contained in the SP, right? Copy the data in the address to the internal RAM address contained in the stack pointer. That is, in the stack pointer, that is the internal ROM address, that is the stack pointer. Similarly, it will remove that address from the stack pointer by using this particular instruction, right? And This is about the push and pop instruction. And other data transfer instruction, we have two instructions. One is XCG, another one is XCG, XCHD, right? XCH and XCHD. It is nothing but it exchange the instructions between the source and destination, right? You know what is exchanging? What the information between you can see here, if it is A comma RR, the information in the RR will be changed to accumulator, and the information in the accumulator will be changed to R. Right. Similarly, the information in this address will be exchanged with the accumulator value. Similarly, here also the content which is present, that is the address RP, right? That particular content will be exchanged with the accumulator. Similarly, here what does XCHD means, right? You got to understand the difference. XCH, it will just exchange the data, the complete data itself, right? But XCHD, what it will do is it will exchange only the lower nibble. The upper nibble is unchanged. It will change only the lower nibble. You can see here, exchange only the lower nibble between A and RP, right? So whenever it comes to SCHD, then the upper nibble of A, right, it will remain unchanged, right? Only the lower nibble will be exchanged, right? So this is the summary about the data transfer instruction. You can see almost all the move instructions uses all the addressing modes: direct addressing, indirect addressing, register, immediate addressing. Push and pop can use only direct addressing, right? Because we are going to push the information only to the stack pointer, right? And similarly, the exchange instruction you can use for direct, indirect, and register. And here XCHD, it is used only for indirect addressing. And these are the execution times of each and every instruction, data transfer instructions, right? The same thing, what are the different instructions which is used for external data RAM and for program RAM? Just a summary about whatever we saw so far, right? So today what we have seen is we have seen the data transfer instructions of 8051. I believe this video will be very useful for you. Thank you, my dear students.
தேங்க்யூ ஸ்டூடெண்ட்ஸ், தேங்க்யூ ஃபார் வாட்சிங். கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். சப்ஸ்கிரைப் பேஷனேட் ப்ரொஃபஸர் அண்ட் கீப் லேர்னிங். தேங்க்யூ வெரி மச்.